I'm Anil Kumar, sharing with you a question posted by my subscribers. Let me first thank them for taking interest and asking such beautiful questions. Now, in this particular video, we'll learn about greatest integer function. So, what I've done here is I've first written the definition of what greatest integer function is, and then we'll solve a question based on limits. The question here is about greatest integer functions, which are defined as follows. The greatest integer function, and written as this, sometimes we also write them as these brackets, kind of double line on this side. So sometimes like this. Now, so these square brackets. So the greatest integer function, which is written in square brackets, is the largest integer that is less than or equal to x. That is how you define it. And what we need to do is to find the limit for this function at different points. So the question here is, evaluate the following limits for greatest integer function. Limit when x approaches 2, when x approaches 1 from the right side, when x approaches minus 2 from the left side, when x approaches minus 3.5, and in general when x approaches minus n from right side. So these are different limits which you need to figure out. Some of you can always pause the video, answer the question, and look into my suggestions. Visualizing these values is kind of difficult. So what I will do here is sketch a graph to represent the greatest integer function, right? And then we'll read the values from the graph. That's the whole idea. Okay, so to sketch the graph, let me that's okay. So I'll make a rough sketch here. So we are interested in values from 1 to 4 basically. Okay, so let me write down, this is 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. Similarly, we'll do here 1, 2, 3, 4, and so on. Minus 1, minus 2, minus 3, minus 4. So as you see, the definition is that the greatest integer function is the largest integer that is less than or equal to. So basically, if the value is greater than 0 slightly, integer is 0, right? And up to, let's say, 1.999, it is 0. When it becomes 1, it jumps to value 1, so it becomes 1. So that is the least integer, 1. And then when you increase up to 2, so at 2 it jumps. And then the same thing repeats. Do you see that? So that is how you could actually graph your greatest integer function, right? So this is what we are doing. We're doing graph of greatest integer function. Books normally use this sign, so I'm using the same. Follow this pattern. It's kind of difficult to understand for negative values. Just follow this pattern. I'm sorry to say that, but that's what I feel, looking into response of students. So, and then we'll try to understand why it is so, okay? So we are just following the pattern for the time being. So just be with me. And then we just kind of, do you see what I'm doing? So this filled in hole or the circle is to the left side, and we are saying that left side or a number line is always lower, right? So less than. Does it make sense to you now? I think it does, right? So that is how it is. So it is kind of like this, okay. So we have some values here, 1, 2, 3, 4, and this is negative 1. Let me write like this, negative 1, negative 2, negative 3, negative 4. We always break rules just for convenience, but I think sometimes it makes sense because I don't want to mess with this side where we have the meat, right? Okay. So now let's answer the question. First one here is, what is the limit of greatest integer function when x approaches 2? So when you are approaching 2, you have to approach from both the sides, left and right, and you see from left side it is approaching the value 1, right? and from the right side you approach the value 2, and therefore this is a step function. There is a discontinuity. It does not exist. Right, so we have a jump discontinuity at this point. Is that clear? Okay, let's move forward. Now we are saying limit of x when x approaches 1 from the right side. So we are approaching 1 from the right side. So you are on this part of the step and you're approaching 1. So this is definitely 1. Is that clear? So you're kind of approaching from this side. So you're approaching 1. Then we have the limit of the function when you're approaching -2 from the left side. So -2 from the left side, you kind of here. So if I go kind of down here, I get to this value, which is -1, -2, -3. Do you see? So I get -3. So it makes sense. Greatest integer lower than -2 is -3, right? All these numbers on the number line on the left side are lower. 1 is lower than 2, 0 is less than 1, -1 is less than 0, -4 is less than 3. You get the idea. Now let's get to this one. It says limit of the function when x approaches -3.5, -3.5 somewhere here. So you're approaching this point from both the sides. Either side you approach a value of -4, and therefore this is -4. So in between you approach a value, but at the edge the limit does not exist. But if you are approaching from the right side, you see you approach this value itself, and 1 we approach, right? But if you are approaching from the left side, as we did for 2, you approach lower value. Perfect. So here in this case, we are approaching -n from the right side, and therefore we'll approach which value? We'll approach n minus n itself. So the answer is -n. Do you see that? So that makes sense for you. You can just try. So if you're approaching -1 from the right side, that means you're here, right? Right side, then you approach -1. If you are approaching let's say -2 from the right side, you're kind of here, you approach -2. So that is how you could answer this. So this was a real confusion, and I hope with this example it is clear to you. You can write your comments, and still if you have some questions, I'll be more than happy to answer. I'm Anil Kumar. You can always share and subscribe my videos, and if you like, you can put a like. Thank you, and all the best.